Hello, good afternoon. Mr. Mike here from Mike's IGCSE Learning Center. Today I'm going through the October-November 2024 paper 620/41. Now, I'm not just going to run through, I will teach you some important ideas that you'll probably find very useful and a lot of advice. You as students, I've been teaching for a long time, so I will probably be able to guide you on how best to handle these questions. Okay, let's look at number one. A list of chemical and physical properties A to H is shown. Now, first thing class, don't jump into the questions. Look at the list. Familiarize with all the words here. They're given you the options: combustion, diffusion, melting, neutralization, photosynthesis, reversible reactions, roasting, thermal decomposition. Run to the list. Now, the list is relatively easy. So now let's go on with the questions. Now, important that each letter may be used once, more than once, or not at all. So be careful, huh? And then another important thing is you just need to use the letters. You don't have to spell out the whole word. All you have to do is the letter. So let's look at it. What happens when an acid reacts with an alkali? Now, if this were a free question, there are a lot of things which happen. Acids react with alkalis to form salts and water. You can use an indicator and the color changes, but all that is not necessary. Why? We are restricted to only these words. So the best we can use is neutralization. So you just place the letter D and you get your full answer, right? Let me thicken that a bit. Okay, that looks better. Now, reaches a position of equilibrium. Now, these are systems where the forward reaction is equal to the backward reaction. So when do we have a forward and backward reaction? It must be your reversible reaction. Next, involves particles changing from a fixed position to mobile but still touching. Mobile still touching, you're looking at a liquid. But fixed position, so we recognize it must be vibrating about fixed position. And of course, now we recognize that it must be melting. Okay, so what are the physical changes? Of course, melting is one of them. Anything else on this list which is a physical change? Now, the best that we've got here would be diffusion. So that would be your answer, diffusion and melting. Now, E is caused by gas particles colliding with each other. Okay, this one a bit tricky, a bit odd. Caused by gas particles, because the closest we've got, class, is diffusion, where we recognize it's usually moving in between the spaces. But if you look at the entire list, the closest answer we can get is diffusion. Gas particles. So this is an important idea, class. Sometimes you don't choose the correct answer, you choose the best answer. And in this case, I would say this is best, because I personally don't think it's so nice, caused by gas particles colliding with each other. Because in most of our models, we recognize gas is mostly empty space. Okay, but anyway, I'm not here to argue with the examiners. The answer is B. Now let's go on. This is a question about atomic structure and the periodic table. Define nucleon number. I think all of us know this. What is nucleon number? The sum of protons and neutrons. Try and say in the nucleus. The sum or the total number of protons and neutrons. But for more complete answer, you would then go on to say in the nucleus. of an atom. That seems a bit more complete, though you should get your full marks if you say the total number of protons and neutrons. Now, state the connection between the number of occupied electron shells in an atom and the period. Now, this one needs a bit of thinking. Let's look at magnesium. Magnesium is magnesium 12. I expect my students to recognize all this. Now, you'll notice magnesium has 3 occupied shells, 1, 2, 3, and magnesium is also on the 3rd period. So if you're looking at occupied electron shells, they never mention fully occupied, they just use the term occupied electron shells and period. You recognize they must be the same. Why? Magnesium has 3 occupied and it is in period 3. Likewise, let's take oxygen. Okay, I'll erase this after. Oxygen is 2.6, remember? It's in period 2 because it's got 2 occupied shells. I should have used fluorine lah. Okay, 9, it's 2.7. So, you got that idea? So, it's 2 shells. So, what is the connection? They are both the same. Agree? Okay, now write the electronic configuration of the following atoms and ions. Again, my students, and I want to encourage all of you, please memorize your first 20 elements. So silicon is immediately 282. Chlorine is 287. But hang on, look carefully, the chloride ion, not the chlorine atom. So it's charged with a -1 charge. So you must add 1 electron. So your correct answer will be 288. Right? So we print that out carefully. Of course, class, I'm teaching you all. So that's your final answer. So I want you all to enjoy the learning process, not just memorize my answers. It doesn't work that way. Try and understand every line I give you. Okay, let's go on. Now, sodium, we've got 11 protons. Remember, in general, if this is the proton, the number on top, the nucleon number is proton on neutron. Proton plus neutrons. So the 11 protons. So how do I get that? I just minus off and I get 12 neutrons. And the number of electrons will be the same because it is not charged. So it's back to 11. Now look at this. 9, 10, that makes sense. Now by the charge of -1, so this must be 10. Agree? And then we've got 31 protons. So who or what element has 31 protons? Okay, this is where you need your periodic table. So we've got gallium, right? With 31. But the total number of 38. Total number of protons plus, this is 31. So remember the number on top, the nucleon number, you need to add up protons plus neutrons. So what you end up with? 69, right? 69. And now, how about this? It's got electrons, which we are short of electrons. There are 31 protons, that means plus 31, but there are only 21 electrons. So there is a shortage of 3 electrons. So therefore it is positively charged. Clear, class? Okay, if you're not too clear, think about it, take your time, pause, and continue the question. Okay, let's go on then to E. A sample of thallium contains 2 isotopes. Define isotopes. Very often asked this question. What are isotopes? Atoms of the same element. Atoms of the same element. That means they all have the same proton number, but with different number of neutrons. Class, here I use short forms, but in your exams, please, everything must be spelled out completely. Okay, now, relative abundance of this and this is 37. Thallium 203 and thallium 205. So we work out the relative atomic masses up to 1 decimal place. So what do? You take 203 times 3 plus 205 times 7 divided by your 3 plus this 7. Okay, and what should you get? You will get 204.4. So the reason why I do it this way is if they do have changes, you have to modify as so. It's just not just this particular question, but any question of this nature. Suggest why that these two isotopes have identical chemical properties. As usual, because chemical properties are dependent on electronic arrangement. So how do you answer this? Because they have the same or they have identical electronic arrangement or configuration. That is the way it's arranged. Okay, the shells. Okay, so because chemical behavior is dependent on electronic arrangement. Okay, now let's go on to number 3. Copper 2 sulfate has the formula CuSO4. Aqueous copper sulfate is a blue solution. Okay, a sample. Okay, at this point, remember you need to memorize all the colors of this iron. Copper 2 is blue. Iron 2 is greenish yellow. Fe3 reddish brown. Manganese is purple. All these colors you have to recognize. Okay, now we've got this. Complete the symbol. So copper oxide is a solid. This is aqueous. Remember, all acids only behave like an acid when it is in water. And when things are in water, you call them aqueous. So now you got copper sulfate solution. And we are going to get water, liquid water. Be careful, not aqueous water, liquid water. Remember, oxides with acid, salt and water. If metals with acid, salt and hydrogen gas. Be careful. State one observation which shows the copper 2 oxide is in excess. So one, you can say no more solid dissolves, or the solid remains. The solid remains. For those of you who can remember, the black solid, because copper oxide is black, the black solid still is undissolved, or something to that effect. You don't have to be exact word to word, class. Don't fall into the trap of when you do these passes, looking at the examiner's answers and trying to say exactly the same words. I've been teaching for many years, and to try and copy and paste is silly. Don't do that. Just look at the concepts and use the words. The examiners will still give you your A stars. Describe how aqueous copper 2 sulfate can be prepared from the reaction mixture. Okay, describe how aqueous copper 2 oxide can be separated. That's what I was wondering. Separated. Okay, that's easy. We'll carry out a filtration. Filtration is carried out. Is conducted better. Okay, why am I a bit wordy? Because they use the term describe. So all you have to do is mention the word filtration, but please use the correct phrase to express this idea. Don't just say filtration. A filtration is conducted because of the word describe. Crystals of hydrated copper 2 sulfate can be obtained. Crystals of hydrated copper 2 sulfate can be obtained from aqueous 2 copper sulfate by crystallization. What is meant by the term hydrated? Okay, now many of you may say the presence of water. No, you cannot say simply the presence of water, but you must say chemically combine a substance which is this is a bit chemically combined with water. Molecular water or simply water. Okay, and not say presence, because you, for example, copper sulfate dot, that means we have water of crystallization there. Okay, what is the formula for hydrated copper 2 sulfate? So you write CuSO4, 5 waters. Should give you the answer. Now describe how this crystallization is done. So you're now looking into the physical process, laboratory preparation of forming the crystals. Now if you can remember, what do you do? Describe how you do. You would first dehydrate, boil, heat the solution, boil off the excess water, anything to that effect. Again, HEAT, heat the solution or evaporate the solution. Okay, same idea. Until very important, until UNT crystallization point or saturation point. Short form I'm using. Again, you can't use short form. And finally, after that, not cukup. It's not sufficient. Then what you do? Going on, you must then let it cool down. And I go on, although it's not in the examinings, I cool down and filter out the crystals. My answer is more complete. Class, I'd rather be more complete than under complete. So, yeah, that's how you do it. Next, aqueous copper 2 sulfate undergoes electrolysis using graphite electrodes. State why aqueous copper sulfate conducts electricity. So now we're going into electrolysis, and of course, what's an electrolyte? They must be made up of free moving ions. You can use the term free moving ions or simply mobile ions. You say one of the two, no need to say both. Give 2 reasons why electrodes are made of graphite. Of course, we all know graphite we love because it's inert. But it also has to be a conductor. Okay? So now, describe how the appearance of electrolyte changes during the electrolysis. Now, first, what you do, remember class, you quickly do this. You recognize you have copper ions and sulfate ions, but it's a solution, H plus and OH. But remember, copper will be preferentially discharged because it is lower in the electrochemical series. Now, memorize this. Potassium, sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead, copper, mercury, silver, gold, and this is your position of H plus. So whichever is lower is chosen, and you notice that copper ions are lower. So copper ions are going to be preferentially discharged, meaning as the copper ions come out, the concentration of copper ions become less and less. Therefore, the color becomes less intense, or it becomes lighter blue, or you can simply say the intensity of the color decreases. Describe what is seen at the cathode during the electrolysis. Okay, so you must say describe what happens at the cathode. Now, copper, fresh copper is a pink, it's a pink substance. That means when copper slowly oxidizes, it becomes brown. But when you first see copper forming, it's actually more pink than anything else. Then you must say a pink, not enough, solid forms on the electrode, on the cathode. Again, let me just, at the cathode, which is negative, who is going to be discharged? Copper. So again, this is the full thing which you don't need to know. I'm just trying to make you all understand. So did they write half ionication for anode? This one, of course, hydroxide would be chosen. And the moment hydroxide is chosen, 4 hydroxides will lose 4 electrons to give me 2 waters and an oxygen. But remember, this must always be presented as reduction potentials. Therefore, you need to rewrite it with the electrons on there. So your correct answer will be 4 hydroxides, 2 waters, and oxygen, and your 4 electrons go to the right. Okay, class? Now, state 2 differences seen if the electrolysis is repeated using copper electrodes. Now, this is the trick. Remember, class, I'm going to erase this for all of you, since it's also a teaching discussion. If you've got metals X, in ions X, and this is your negative terminal and this is your positive terminal, what will happen at the cathode, which is negative? X N plus will collect any electrons to give me X metal. Whereas at the anode, something else is going to happen. X metal will dissolve to form ions, but again, we must always write it as reduction potential, so we write it like as such. Okay, so once you got the idea, then what do you see? So first thing, state 2 differences repeated using two differences is one, color will remain constant. Why? Because concentration is constant. For every copper ion being discharged, a copper ion, for every copper ion coming out, there'll be one forming. So the concentration is going to be constant. So that's something you must say, the color remains the same. Okay. Now what else? The anode gets thinner. It's odd, huh? You could also say the cathode gets thicker, but that's not in the marking scheme. Another one they have mentioned is no bubbles are formed. Just to tell you, no bubbles are seen, which is a bit odd. So far got it, class? Okay, so now we go on with the next question. When magnesium nitrate is heated strongly, magnesium oxide is formed. The equation for the reaction is shown. State the oxidation number of nitrogen in this reaction. So now first you look at this nitrate ion has become nitrogen dioxide. Now remember, a nitrate ion has a charge of -1. So the -1 you put there, right? That's the charge. Because nitrogen, let's assume we don't know what's the value first. And we've got 3 oxygens. Remember, oxygen in a compound is always -2. So X will be equal to -1 plus 6. So you get plus 5. So initially it is plus 5. Okay. Now when you say oxygen is always -2, not necessarily, but usually it's -2, there's a list of rules that you all must be comfortable with. But that takes a full lesson for redox. But now I want to do something a bit faster. So how about this nitrogen now? Now the whole thing is not charged. So there's no charge, so you write it as 0, no charge. No charge here, class. That's what I mean, no charge there. Yeah, that's looking a bit confusing, but there's no charge. It's not nitrate ion. We're looking at, I'll call this Y. Y, and there are 2 oxygens. Oxygen is -2, so Y will be +4. So that's why you get it from +5 to +4. Not 5 to 4. Oxidation states, even if they're just 5, you must say +5. Now, so this guy has from +5, he's gone to +4. So he must have gained an electron. So if nitrogen is gaining, remember the word oil rig. Oxidation is the loss, reduction, oil rig. Oxidation is the loss, reduction is the gain. So this has been reduced, which obviously means the oxygen here must have been oxidized. Oxygen must have lost. So here, identify the element which is oxidized. It is oxygen. Got that? Okay, now let's go on. Looking messy. Let me clean up this mess here. Let's go on. Calculate the volume of nitrogen dioxide gas when 7.2 grams of magnesium nitrate is heated. They have been very kind and they have given us the steps. First, work out the relative weight of magnesium, relative atomic formula mass of magnesium nitrate. We've got magnesium, which is 24, plus nitrogen, which is 14, oxygen is 16. There are 3 of them, whole thing times 2. which will give you 148. Right? Relative, so there's no grams there. Relative means compared to. Whenever you compare to, there's no units. Now, calculate the number of moles of magnesium. So, N, the number of moles of magnesium nitrate used will be equal to, okay, what's the weight we've got here? They told us they are using 7.4 grams over our 148. Now that should give us 0.05 moles. Therefore, so we've got 0.05 moles. The number of moles of nitrogen. Now you look at the mole ratios. Look at the mole ratios. 2 gives me 4, double. Therefore, 0.05 will give me 0.05 times 2, double, which will be 0.10. And then, remember for gases, what formula? And the number of moles of gas will be V over 24,000 cm cubes. Then this is in cm cubes. If it's in dm cubes, then it will just be 24. So we enter this formula, 0.1 equals to V times 24,000, and we should get V equals to 2,400 cm cubes. Got that, class? Okay, so now class, we continue with question 4b. Now, magnesium oxide, MgO, is an ionic compound. Remember, ionic involves the transfer of electrons. Ionic compounds, the metal donates to the non-metal. The metal will become positively charged, the non-metal will be negatively charged. Now complete the dot and cross diagram in the ions of magnesium, of the ions in magnesium oxide. Give the charges of each of the ions. Now remember, magnesium, the first 20 elements, I expect you all to know, it's 282 before reaction, and then we've got oxygen with a proton number of 8. The electronic arrangement is 2.6 before reaction. Now, so what's going to happen is magnesium is going to donate its 2 outermost electrons to oxygen. So it will be left with 2.8. So you draw your 8 here. So 2.8, and now it has lost 2 electrons. So you'll have a charge of positive, 2 positive, right? On the other hand, now let's look at oxygen. I'm going to do it in blue for you to understand. You've got 2 of the inner electrons, that's the 2 black dots there. So we'll have another 6. 1, 2, 3, 4, 5, 6. Okay, draw it nicely, not like what I did here. And then, don't forget the 2 electrons which came from magnesium. You do that with the crosses, and that will give you a charge of 2 minus. Got that, class? Okay, now we go to our oxygen, the covalent molecule. Now, if you can remember the structural formula with all the bonds, then life becomes a lot easier. So we have a pair of shared electrons. Remember, covalent bonds come about from sharing of electrons. Sharing, okay? So ing, spelling a bit out there. Okay, sharing of electrons. So again, oxygen, remember, is 2.6. So 1, 2, 3, 4, 5, 6. right? Then we look from this oxygen's point of view, 2 inner shells. So X's now 1, 2, 3, 4, 5, 6, right? And this is your covalent molecule, the oxygen covalent molecule. Okay, class? Good. Now we go on to number 5. Now, hydrogen is the first element of the periodic table. Hydrogen is used in fuel cells to produce electricity in vehicles. Name the substance which combines with hydrogen in fuel cells. Of course, that is your great oxygen. Right? Oxygen. Now, give one advantage and disadvantage of using fuel cells instead of gasoline in vehicle engine. Angeline's my wife name. Okay, in vehicle engines. Advantage, of course, the only product is water. So that's the advantage. A clean product, water. So water is the only product. Okay, why is that such an advantage? Just incidentally, because remember that a lot of fuels come with some toxic substances which are given off. For example, all our fossil fuels, which include coal, petroleum, gas, natural gas, they all have sulfur in them. And of course, you know when sulfur burns, you have sulfur dioxide, which then becomes sulfur trioxide, leading to acid rain and blah blah blah. So here there is no such impurities. But what's the disadvantage? The storage of hydrogen tends to be what's most difficult. So we can say hydrogen is hard to store, or you require heavy tanks to store hydrogen. The weight of the heavy tanks is what you're going to have to carry around. So that's a huge disadvantage. So I would say the heavy tanks required to store your hydrogen. Remember, it's a gas, and usually under high pressure this is stored as liquid hydrogen. So that's why you need thick, heavy metal tanks. Now on to B. Hydrogen gas can be made from petroleum by a two-step procedure. Petroleum, be careful, petroleum is also our crude oil. Don't mix up the two. Petrol in Malaysia especially versus petroleum. Petroleum is crude oil. The lium is not petrol. Anyway, step 2, large molecules obtained in step 1 are converted to smaller molecules including hydrogen. Now name the process. I think rather direct. So this is fractional distillation. And name the process used in step 2, that is cracking. By now, I think some of you all will realize I'm a bit dyslexic. My spelling is a bit screwed up, but that doesn't stop any of you all from getting your A stars. So C. Let's go on to C. Organic compounds contain hydrogen. Calculate the number of hydrogen atoms in 44 grams of ester ethyl propanoate. Okay, calculate the number of hydrogen atoms in 44 grams. Okay, first we work out, okay, step number 1, what is your relative molecular mass of the entire ester, the whole ester? So we work that out, and you can work out one by one. I think no problem. That should just work out to 88. Next, how much, okay, so here in this second, number 2, how many moles do I have? So use the formula N equals to X grams over the relative molecular mass of X, and here we've got 44 over 88, and that gives me 0.5 moles of the ester, right? But when we have so many moles of the ester, so what's our step number 3? So we take our 0.5 times 6 times 10 to the power of 23. But be careful, in one whole molecule, how many hydrogens are there? 3 plus another 2, 5 plus another 3. So you multiply by times 8. So giving me the final answer of 2.408 times 10 to the power of 24. So that's the number of hydrogen atoms. Getting it, class? Okay. So now, part D. For each of the homologous series shown, name a member that contains 6 hydrogen atoms. Of course, with alkanes, the general formula is CnH2n plus 2. With N, we set N equals to 6. Oh, sorry. We set hydrogen. Look, hydrogen atoms. That means 2N plus 2 equals to 6, which means N needs to be 2, right? Because if N equals to 2, what do we have? C2H6. So we are looking for species with 6 hydrogen atoms. So what is this? So we recognize, of course, that's our great ethane. With alkenes, general formula for alkenes now is CnH2n. So with N, hydrogen being 6, we notice that N has to be set equal to 3. So we got C3H6. And what is that equal to? It's propene. Right, class? Okay, alcohols. I'm going to erase this bit here. Right? Again, alcohols, general formula CnH2n plus 1 OH. We need to set the hydrogen equal to 6. Don't forget, there's 1 hydrogen here. So if I set N equals to 2, we have C2H5OH, a total of 6 hydrogens. And that we recognize is our great ethanol. How about carboxylic acids? General formula for carboxylic acids, it's CnH2n plus 1 COOH. Again, another hydrogen there, don't forget. So same thing here, you set N equal to 2. And you have C2H5COOH, giving you a total of 6 hydrogens. But be careful when you name, always with carboxylic acids, my students forget this hydrogen. So there's a total of 3 carbons, not hydrogen, 3 carbons. So 3 carbon systems, it's a prop. So it's propanoic acid. Got that, class? Now go on to E again. Let me erase this. Again, you can pause and enjoy the lesson. Don't rush. I'm also taking it slow and easy. This is a teaching past year question I'm running through. I'm not just running through. I want you all to understand. Well, okay. E. Unsaturated alkenes are converted to saturated alkanes. Alkenes to alkanes by reaction with hydrogen gas. State why alkenes and alkanes are hydrocarbons. I think we know this. Many of you would know. But it's because they are made up of okay, second, contains carbon and hydrogen. Don't forget the great word only. You must state that. The examiners will always put that in bold. Why? Because we've got things like alcohols, carboxylic acids, esters, which are made of carbon, hydrogen, and oxygen. That's why you need to separate that hydrocarbons are made up of carbon and hydrogen only. State why alkenes are unsaturated. Okay, this is a textbook answer because they have a carbon double bond. Carbon, don't forget double bond, right? Name the catalyst needed to convert alkenes to alkanes. Now, can you remember how alkenes, nickel at 180 degrees Celsius. They didn't ask temperature, they just named the catalyst. So you write nickel, the transition metal. Explain why the conversion of alkenes into alkanes is an addition reaction. As usual, the moment there are two types, addition versus condensation. So addition, the answer is because you have only one product, right? That's when you say addition. If they use the term condensation, then there'll be two products. And what are the two products? The products will be the polymer, the long chain polymer, and a small molecule. Okay, so for here, we're looking at addition. So that's the correct answer. One product only. Okay, let's go on. Next, 6. Natural polyamides are polymers made from amino acid monomers. State the type of polymerization that occurs with natural polyamides. Like I said, this would be a condensation. Because condensation. Two types, remember, polyamides and our great polyesters for your IGCSE syllabus are both condensation. Next, name the term given to natural polyamides, and these are our great proteins. Okay? So remember the linkage for polyamide. What is the linkage? Just before you L-I-N-K, linkage will be, you're looking for this group, a con. Just remember a con. And how is it structurally? Structurally, it will be a C double bond O attached to nitrogen H. Always remember this link. Okay? CONH. So now, going on to C. An amino acid is represented as shown. Complete to show figure. Show all the atoms and all the bonds in the functional group. An amino acid is represented as shown. Complete. Okay, so you have to have a C attached to a C double bond O H. The other side will be NH2. That's one amino acid, and this one is some methyl group, an R group, methyl, ethyl, propyl. R is always of the form CnH2n plus 1. So we just represent it with the R, and your examiner should give you your full mark. Oh, C double bond OOH. Sorry, class. COOH. I made a mistake there. So CNH2. Okay? So let's go on. Use of R, I would like if you all wrote this R, although the examiner doesn't require it. It shows that you know your stuff, class. It also helps you as a student understand what you're doing. Right? Now, going on. Next, 3 different amino acids are represented. Complete the diagram to show the structure of the natural polyamide that forms when the 3 amino acids are combined. Again, you're looking at for this linkage CONH. So what you draw first, okay, that's a C double bond O. Okay, draw it nicer than me, class. Drawing O, and okay, now wait, I draw it, making color for you. So this is your N H, right? Then, so I'm drawing this part now. C double bond O. Then again, now back to this. Sorry, now I'll use the black there. Yeah. So N H. COOH. No linkage there on this side. It's just NH2. So 3 are connected together, 3 amino acids. Next, E, a mixture of 3 amino acids AB can be separated and the amino complete the equation. What is RF? It's called your retention factor, class. So what is retention factor? Distance moved by my substance or my species over distance moved by the solvent. Again, a reminder, you need to fill in up with complete words, no short forms. That's a moved, M-O-V-E-D. Right? You got that? E. A sample of mixture of 3 amino acids A, B, and C are placed onto the baseline and a chromatogram is allowed to develop as shown. The finished chromatogram is shown in figure 6.6. The 3 amino acids A, B, C are colorless. Water is used as a solvent. Explain why the baseline is drawn in pencil. Because pencil, of course, the pencil is insoluble, it is inert, so it won't mess up your chromatogram. So pencil is insoluble. Right? Next. State the type of substance used to make the colorless amino acid visible. This is, of course, your locating agent. Now, don't use the term ninhydrin, because the examiners from now on prefer just the term locating agent, and this is the newer syllabus, so we stick to this. Explain why figure 6.6 shows 2 spots are shown as opposed to 3. How come the third one didn't show up? Obviously, it must be having the same RF value. Look, wrong answer. Hence, you might say, hence, it moves up to the same point. Yeah? And suggest how the experiment can be changed to separate 3 amino acid. Use of a different solvent would be a good answer. You could also say use of a mixture of solvents, but the examiner only mentions use of a different solvent. So let's stick to them. Okay, class? I hope you understood that. And if you are, I'm going to also release the 42 and 43 variation. I think if you were to also go through that slowly, steadily, you've got more than 2 months, you will definitely improve. Okay? I hope you enjoyed the learning process, and I hope you enjoy chemistry. I also am doing this for physics, maths, and admaths, but for now, let me just finish off with the chemistry first. Okay, all the best to all of you. Enjoy your learning. Bye.